We're going to do part of activity 4.5, cams in motion. Once you have that open, scroll down till you see cam dimension drawings. We're going to be doing these drawings. We're going to concentrate on a Pear Cam for this video. Notice that the dimensions are equations. That means when we go to Inventor, we're going to have to use equations if we want to work parametrically, that is. So, standard part. I'm going to go to Manage first before I go. I can go afterwards, but since I know I'm going to make it parametrically, I'm going to go ahead and click on Parameters, add a number, and the first one is D is equal to 1. So that's going to be my first value. I'm going to add the second value, which is going to be whole, which is going to be equal to 3 divided by 16. And you get those numbers from your dimension drawing. So now I'm going to hit Done. Now you may have to pause a couple times as we go through this because the first time it's a little confusing, but after that it gets pretty easy. So now I want to sketch, start a new sketch. I'm going to start on the XY plane. I'm going to type in circle, click, and for the dimension, I'm just typing the word whole. Notice it has a little FX there because it is a function now from those parameters. So now I'm going to do another circle, and I'm going to hit D for dimension, and I'm going to dimension this, but I want to change its dimension type to radius. And that's because the dimension is given to me based on the radius, so I'm going to say it is equal to 1 divided by 4 times D. A lot of students will forget to put the multiplication symbols and division symbols in there, particularly multiplication. Now I need to know how big that is, or distance-wise, from here. And looking at the drawing, it's 1/2, so 1 divided by 2 times D. So I have that dimension. So now I'm going to do the next circle, and it comes such that it's concentric to this one. So I go ahead and force that constraint there. And I'm going to hit, there we go. Right click, dimension type, radius. And for this one, its radius is 1/2 D. And if I didn't want to do it that way, I also could say D divided by 2 or D times 0.5. There's several ways you can do it. It's not really important. Next thing we do is draw some lines. I'm going to draw some really long lines out here. And I'm going to hit L to start another line. They don't need to be attached. I'm going to make them extra long. And then I'm going to constrain them using tangent. So I want this tangent to that, and that tangent to that. Now notice it brought that a little askew. Don't worry. We'll use the vertical command. Students get in the habit of wanting to start all over. Use your constraints to your advantage. So hit here. And I want to make sure it looks like it is, but I can't be guaranteed. Now I know. See, I can see it's tangent in both places. Now I'm going to trim out some things I don't need. I don't need that. I don't need that part. I don't need this long line. I don't need that line. And now start taking some of the center stuff. Now I have the shape I need. Now all I have to do is extrude. And according to the dimensions, it says it's 3/16 of an inch, so it's as thick as the whole. You could have created another parameter also if you want to say called thickness. That would have been fine to do too. Matter of fact, we could go back and now look at our manage, look at our parameters, and notice there's all of our equations. So if I didn't feel comfortable with that, I could add another one that says thickness. Make it equal 3/16. It accepts that, and then where this says whole, I can now type in thickness. Notice it went from red to black. I'm done. So now when you go back and look at it, we have our parametric equations up here. And now if I decide all of a sudden, you know what, I really think D should have been 2 because it was just boom. Everything enlarges accordingly. Now if I wanted to, I could also make that smaller. Sometimes if you get them too small or too large, it'll have a little difficulty with because the numbers will not work out mathematically. I also could have made whole a function of the D if I wanted it to be perfectly parametric, but in this case, probably the thickness of the dowels I have will be a driver on what I make those. So that'll allow you, if you make your automaton and it's all of a sudden you find out it's too large, you can just parametric